Hello, it's Cliff here, Toolmaker from Down Under. In this video I'm going to show you how you can do accurate part setting. When you're machining a part in the lathe, you machine one portion, how you can transfer that accuracy to other portions of your part and get accurate radial alignment and angular alignment. It'll be based on machining these spindles for ThreadExpress. If ThreadExpress is new to you, it's a indexing and thread milling attachment, and now the plans, the technical drawings and other files are available for download from my website. If you go to the end of this video, or when you get to the end of this video, you'll see a section there explaining how you can navigate to the website and obtain those files for yourself. This is going to be how you can set the work up and maintain concentricity through datum surface transfer and do really precise machining work. With those techniques, I will outline that in this video. Thanks. Little local drawings of the particular machining operation you're doing and the orientation that's useful to you from the reference surfaces that are useful to you. There's lots of benefits in doing that in advance. It gets your head around the key dimensions, and also it frees up your brain when you're doing the machining to concentrate on the machining and not get bogged down with trying to reverse images in your head and reverse numbers and remember numbers. But you just glance up at this on a clipboard and you can use more of your brain for the key part of the actual machining. Okay, so we've roughed out the spindles, we've finished, machined and lapped the thread. Now we've got to finish the bearing diameters at each end and the ER32 nose, so that we can both hold collets and have a backplate screwing onto it for a 3-jaw chuck. Now, how do we get the concentricity maintained between the thread, the bearing diameters, the collet and the chuck mounting? It's really important for a spindle to be concentric. It's really important for a ThreadExpress spindle to be concentric. I did a video a few videos back, a series of 3 videos called Advanced Machining, I think, and I go into a method there that I'm going to explain again now in this series, because this is a big tip that saved me many hours and got me through many difficult tool making jobs over the years. So I'm going to call it alignment surface transfer, or concentricity datum reference surfaces, and it allows you to do precision machining very quickly. So in the case of the spindle, as you've probably seen from the recent video, I have cut the thread soon after roughing out the part. That's because if you make a mistake with the thread, which is reasonably high risk, then you haven't spent days doing all the other machining, and then it all just goes in the rubbish bin. So it allows you to do the most risky part of the machining first, which is the thread. Then you probably saw me just do a witness surface or a datum surface on this diameter here, and I skimmed under the head. Now what that was for, I'll be showing you in a minute, but there is 2 main types of alignment in a lathe: radial alignment, concentricity, so the part has to run true, but also angular alignment. And if you can establish a reference surface, which is this surface here and under the head in this case, then you can set the part up again and with a finger indicator and check that you have the previously machined surface, which is this thread, running concentric very easily. I'll show you it in the lathe now, but that's an introduction to this really key tip. Okay, now I've set the spindle up inside my 3-jaw chuck, and I want to machine this end of it, the ER32 thread and internal collet taper and so on. And the quickest and easiest way to do that is that have it just standing out from a chuck. But the problem is, how do you know whether or not it is concentric with the previously machined thread? It must be very concentric, obviously. And this is where the finger indicator comes in. It's a fantastic setting instrument, and if you have that reference surface or datum surface that I mentioned, that I skimmed that surface and under the head when it was being thread cut, then we know that is concentric and we can set up off that. See if I can show you where the finger indicator ball is mounted. See the ball of the finger indicator there? Under that head, right there. So let's get back up on the top again. So now, when I rotate the part, I can set that surface to be in alignment, in angular alignment, not concentric radially, but in angular alignment. That's the first thing to set, and I do that by putting a copper drift or aluminium drift there, rotating the part to the high spot and tapping it with the chuck nipped up reasonably tight, and it'll jostle and bump around in there until you can get it very accurate. I won't try and do it while the camera's running, but just to give you the general idea. So there's my drift. I get the high spot and I tap it, and initially you'll probably make it worse, and then you'll slowly realize I need to tap it less and tap it on this angle at this point in the rotation. But once you learn that skill, you can set up a part in a matter of a minute or so and get it true in one direction. That is in angular alignment. Now, because the chuck is mounted on its back plate in a way that allows it to float, I've mentioned this in previous videos, where I have cap screws that are just nipped up with spring washers under them. I can float it around to get concentric in the other direction. It's already in angular concentricity, then I can get it in radial concentricity. Then I know the thread is running true. And of course, it needs to be very accurate. If I have a run out there of, say, 2 microns or 1/10 of a thou, that equates to about a 1/2 thou run out down the other end. So, you know, it must be set very accurately. So I've mounted this in my big lathe because it's quicker for screw cutting, but it equally fits in my small lathe. So, you know, most chucks, medium-sized lathe chucks, have got quite a lot of capacity. You can actually bore your 3-jaw chuck out to have more capacity to allow you to do more of this type of work. So now I can go on the other reference diameter that I've machined and check for radial concentricity, and you can see there it's quite a lot out. But because my chuck is mounted on a floating back plate, or you could have an adjustable chuck, but you know, just having clearance on the screws is sufficient. I just nip them up, and then when it is at its highest point at the top, which is there, you tap the top of the chuck, because the chuck wants to go straight down with gravity, and a little bit of encouragement. When it's just nipped up, bump, bump, it'll go down and very quickly set it concentric, and then you can tighten up the mounting screws and have it true in both directions. I'll just set the camera up on a tripod now and show you that. And then you've got it true in both directions. Now the big advantage of this is when I rough it out, it's possible that it would move, the part would move due to distortion or due to too heavy a cut, shifting in the chuck, but I've still got my reference surfaces there, and I can, before I take the finishing cut, check them one more time if I'm at all concerned that it may have moved, and realign it again. Okay, let's see if I can demonstrate this. So if I push down on the indicator stand here, you can see the direction the needle goes. It's going clockwise. So we rotate the chuck to the most clockwise position. That's showing the work fully up. That's the way we want it. And then we tap it. Now already we're much closer. Rotate it to the most clockwise position. And you can see by that method, I won't take up too much of your time, but you get the idea. Well, there you go. I've got it within about 2 microns now. Off camera I'll get it a bit even closer than that, but that literally takes 10 seconds. Now I can tighten up the screws on the back plate, and I have the part running true both axially and in angular alignment. Now also I have to tighten the chuck up a little more, the jaws up a little more, and check it again, and I may need to make a little bump here and there, but you know, I'm just trying to get the essence of this tip across to you. So after I've tightened the chuck up, I can flip the indicator around the other way and just check that it hasn't moved, and also now I can rough it out, and just before I do the finishing cut, check one more time that it is still concentric in both directions. You remember at the beginning of this video series I talked about the importance of planning your machining procedure through. I'm doing a little series of notes or sketches, and that's a good example of that. Like here you can remember to machine a reference diameter when you're at the screw cutting and lapping stage on that diameter. You can make a note to set it up with a finger indicator at that point, and so on. That way you have a procedure that you can either stick to or improve, but you know there's no gaps or blocks in the procedure that stop you from actually doing the job. You know, it's very easy to have a gap or a block in your procedure if you haven't thought it through properly, where you can't set the part up, or where you would damage the part, or you wouldn't get enough accuracy. So it's worth thinking through the different stages of the machining procedure so you don't paint yourself into a corner. You can also fit an indicator in there to read the diameter also. It's amazing how they fit into tiny little gaps. So you might deliberately decide to only set it to within, you know, half a thou initially, rough it out to the finishing cut, and then finally get it exactly true. But it's a good plan to check it before you take the finishing cut. Now, of course, I'm not saying this machining procedure is best for every operation. You may well decide to machine the spindle bearing diameters at the same time as the thread. Nothing beats that for accuracy. And then running them later between centers, or using a fixed steady. You know, it obviously depends on the number of parts you're making, and the type of tolerances you want to meet, and a whole lot of variables depending on the design of the part, and endless number of variables. But if you think the procedure through and make your decision in advance, you're more likely to get it right. Well, let's just talk briefly about what's available online. So if we go to our internet browser and start typing in the website address, which is hallmarkdesign.co.nz, we'll get to Hallmark Design's website. This is the website where I sell the probes that I make and so on. But if you look right over on the right hand side over here, you'll see ThreadExpress. So let's click on there. Now, ThreadExpress is a development hobby project and not part of Hallmark Design, but I'm using their website for this. So in the beginning you'll see links to the videos. You can just watch them directly here on the website. I don't think you get any ads if you do that, but if you click here down in this little bottom corner here, you can watch on YouTube. Let's just click over to there, turn the speaker off, or we'll get bombed with ads. Now if we look over here, there's all of the ThreadExpress playlist videos. There's 18 different videos there, and you can click on those and watch all of those videos. Okay, so let's go back to the website. So now if we scroll down the page of ThreadExpress, first of all there's a PDF that Mark and I put together, just sort of introducing ThreadExpress, 2 pages of text there. And then if we carry on, well, let's just go through that quickly. So you can see there's information and introduction, ThreadExpress history, notes on construction, files and license to build, and YouTube video links. Now if we scroll down a bit further, there's a bit of a memo here. Thinking of building your own ThreadExpress, download of files and license. So some of you will be interested in this. It's a purchase by donation model. Click on the Buy Me a Coffee link below and enter an amount you think is fair. Some terms and conditions there. And then if we carry on down, there's the Buy Me a Coffee link. And then below that is all of the information. So we have 41 technical drawings. This is the main set of plans. So if we click here on the download, we'll just download that now. It won't take a second if my internet connection's working all right. Okay, so now we have 41 plans. So in the beginning there's some nice looking assembly drawings, and then we get down to individual components. So they are in PDF form, so you can print them out in A4, or if you want to go to a printer that's got A3, you can print them out full size. Maybe you want some of the parts printed out full size, and other parts can be just more compact A4s that you can readily stick on a clipboard in your workshop. So right down to finally some sub-assemblies here at the bottom. Mark's made a really beautiful job of these drawings. Okay, so let's go back to the website, and finally there's unusual files that can't be attached directly to the website, CAD files and other special files. So we'll just highlight that big long link there. See, it says here Dropbox files, link below, copy and paste to browser URL. So let's just go back to the browser URL. We've copied and now we're going to paste, and we did something wrong there. So let's try again. Copy. I'm talking too much and not thinking enough, and we're going to pop it in there at that top user URL. And see here, the second one down is in black. We're going to click on that. That's going to take us through to Dropbox. And here you can see there's a folder that's opened, and there's 4 folders within that folder. So you're looking at the Dropbox page, and let's say you want to download your files. So let's just click here on the top ones, the 3 support documents. Just tick them there, and you can see here now you can download. Well, look, let's just download those files. Okay, so up here we have the downloaded files. Open the files, 3 support documents. Okay, let's click on those. So one of those is the stock list. There's stock parts that are available online, if you're lucky. So here Mark has made a list of different components. Here we are, internet links for off-the-shelf items over on the side here. So we can just click on this link that he's prepared. I'll do that now, the top one, 3-jaw chuck. Well, let's do the bevel gears, the second one. That's a bit more interesting. So that's going to take you straight through, in this case, to AliExpress, and you can see the bevel gears. Oh, that's brilliant, isn't it? And so that is the method for downloading. So you want the 5 files for the sheet patterns and sheet metal patterns and scales. You just click there, download to your computer, and then you can open them up with your CAD software, send them off to your sheet metal person to get them laser cut or whatever. Same for all the other files. There's photographs of different key components. Let's go back to, and there's some solid files here, 9 step files for some key components. Some of you will have CNC machines and may want to machine some of the parts up by CNC and drill holes and so on. Okay, so going back to the website, so then we have completed looking at all the various documents that are available. So the 41 PDFs directly on the website, and the link there to the Dropbox for the more complex files that can't easily be loaded onto the website. Well, thanks for watching that video through to the end. Hopefully you found something useful there. If you did, please like and consider subscribing, and also let me know your thoughts in the comments below. Cheers.